In this video, I am going to show you how to set up a potential energy scan along a bond coordinate using GaussView. So first let's draw nitrogen molecule. So go to the element fragment tool, choose nitrogen, left click on the view window, and now we have drawn nitrogen. First thing I'm going to do is to set up initial bond length for my scan. So I will go to Modify Bond tool, choose the atoms that make up the bond that I want to modify, and then set the bond length to 0.7 angstroms. So once I type in the number into the box here, I hit enter. That has changed my bond length. I can see it on the slider here, and then I click OK. Next, I will set up the potential energy surface scan. So I need to go to Tools, Redundant Coordinates. Click on Add and choose the atoms that make up the bond that you want to define. Select Unidentified and choose Bond here. Then click on Add and choose Scan Coordinate. What I want to do is to take 20 steps with a step size of 0.1 angstroms. So in my potential energy surface, I'm going to do 21 calculations. The first calculation will be for the bond length of 0.7 angstroms, and then I will step by 0.1 angstrom, so the next step will be 0.8 angstroms, then 0.9, and so on after I have completed 20 steps. Click OK, and let's go to Calculate Gaussian Calculation Setup. For the job type, we want to choose Scan, Relaxed. For methodology, let's use DFT B3LYP, and for the basis set, choose 631G D basis set. Charge for the system is 0 and the multiplicity is singlet. Let's go to title. We can call this N2 PES scan. So it's N2 potential energy surface scan. And then let's go and click on preview. Okay. So what you can see here is my root section, the title, the section where I define charge and multiplicity, XYZ coordinates of the initial structure. This information belongs to the connectivity information. And finally here you can see the setup for my scan. So B stands for bond, 2 and 1 give me the atom numbers that make up the bond, S stands for scan, 20 is the number of steps, and the last number 0.1 is the step size. So now you can go ahead and save the input file and transfer it to a remote system for calculation, or you can just calculate this on your desktop since this is a small system. So I will just click on Retain. I have done this calculation ahead of time, so what I would like to show you now is how the result looks like. So once you are done with the calculation, open the log file. You can see that I have 21 geometries displayed here, starting from the initial geometry and then increasing the bond length by 0.1 angstrom. You can click on the green circle and that will animate the scan for you. Do the right click on the background and go to Results, Scan. So this is going to show you the scan of the total energy. So this will plot for you total energy versus the scan coordinate, which is nitrogen-nitrogen bond length in this case. So I will just go do the right click, hide other plots. And sometimes you want to display the y-axis in terms of kcals per mole rather than Hartrees. I can change this very easily by doing the right click, going to properties, and then I can pick units for the y-axis. I can set it to kcals per mole, and also I can set the lowest energy to be equal to 0. So I highlight the lowest energy and then set origin to 0 kcals per mole and click on current. So this will give you relative energy in kcals per mole on the y-axis. I can also save the scan data for plotting in my favorite software. Before I save the data, however, I want to recover the original plot. So I will do the right click, properties, go to default and choose factory default, then click OK. So this is my original plot of the scan. Then do the right click, save data, and I already have the directory preset. Click on save. It's telling me the file exists. Yes, I want to overwrite it. And now let's open the file to see how it looks like. Okay. So it's the data is in n2scan underscore total energy text. So I double click and you can see that this is a text file with 2 columns of data. The first column corresponds to nitrogen-nitrogen bond length or whatever scan coordinate it is you are using, and the second column has the total energy in Hartrees. So I should be able to import this file into Excel or into another plotting software and plot it myself.